We good? You hear me? Everybody hear me in the back? Cool. Awesome. Thank you very much for the intro. My name is Patrick Shuff, and today I'll be sharing with you some stories and some illustrations on kind of the origins of the internet, how it has evolved over time, as well as how the internet works, and sometimes it doesn't work. I've been really fortunate in my career to have worked at two of the biggest internet companies in the world, and I've kind of got to see firsthand how the internet is built. I've worked on a few teams and projects who literally, and I use this term in the right way, we're building the internet and expanding to regions and countries where they have very poor internet connectivity or no internet connectivity at all. So it's been really fascinating to see, kind of how the internet works, the internet works, and the inner workings of it. So before I dive into this, first I'd like to thank Tessa, Kevin, Andy, and Kyle. Those guys put a ton of work into the presentations, the dry runs, helping make sure that every month you guys have a really great presentation for someone to come up and present. So with that, if this presentation is not great, I'm going to place part of the blame on them. Yeah. Secondly, I'd like to thank WeWork. It's really great that they're supporting the community and providing the space for us. And we at eFuse are really happy tenants just up on the 5th floor. We've been here about a month and it's been really great. And lastly, I'd like to thank Improving for providing the drinks and the food for everybody. I really love seeing local communities, local companies investing in the community and being able to give not only their time but their resources to help make events like this happen. And I know we at eFuse are really excited to help in the future in sponsoring some of these events. So today I'm going to kind of talk about several different things. I already mentioned we're going to quickly talk about kind of the origins of the internet, how it started growing. Then we're going to talk about how the internet is architected, and I'm going to use some very familiar concepts that you all probably use in your daily lives. Next, I'll talk about how the internet, comparing it to how packages that you order on, say, Amazon get delivered to your door is very similar to how videos or movies are delivered to your device. And lastly, I'll talk about how Amazon and Netflix were solving a very similar problem when they tried to, when Amazon was trying to solve the 2-day shipping issue, where they wanted package to be at your door within 2 days, and how and how Netflix solved their 4K video. Video delivery worldwide and across the nation. So I did have a really cool video here, but for some reason the internet's not working. So I guess we'll just move on. Yeah, that was pretty lame. Sorry. Cool. So who am I? Who is Shuff? And why am I up here talking about the internet? So just to kind of share a brief history about myself, I was very fortunate to grow up around computers. My first computer was a Commodore 64, a long time ago. But I was just, I had computers kind of around for a lot of my life. Although I really never got into coding and programming until college. So in 2006, I joined Ohio State as a very average student. And I joined the computer science and engineering. I always kind of knew I wanted to go into computers, but computer science and engineering just kind of seemed like the right degree for me at the time. So college was fine. It was great. I learned a lot, learned a lot of the theory, but really where I was interested and where I really found my passion was building things outside of the classroom. So my grades were very average, but where I really learned and I really grew during my college years was building things. And that's when I discovered Python. That's when I really fell in love with coding. I fell in love with being able to build things. Python just made things so much more accessible to me as a developer in the the mid 2000s. I just kind of the world was my oyster, so to speak, in terms of what I could do. And I also made a decision back in the mid 2000s to go to Linux, which looking back, I don't know why I ever chose to fully go all in on Linux, but throughout my career it was a really great decision because most of the internet today is powered by the Linux operating system. So While I was in college, I had always worked with computers. So I did different internships where I worked with the state, and I was always kind of working with computers. But following college, I joined Nationwide. So I worked just down the street, and I worked on the Linux team. So essentially what my role was there was we were system administrators for a few thousand Linux servers that powered nationwide.com, all the different applications that make up the Nationwide, I guess, suite or family of products. So Nationwide was really great because I could take all those things I had done on my spare time and learned in college and apply them to real world scenarios. So again, on the Linux team, we're doing a lot of system administration work, and as well as doing the system administration work, if you've ever done it, there's a lot of repetitive things that you do over and over. And I'm kind of a lazy developer. I don't want to do the same things over and over. So I would automate a lot of those things away in Python. So, Nationwide was a really great role for me to kind of expand and apply all the things I had learned into a production setting and, get things done. So about a year and a half into my role at Nationwide, I was pretty happy there and I was not looking for a job, but a recruiter from Facebook hit me up on LinkedIn asking me if I wanted to interview. I didn't think I had a chance in heck of getting a job there, but fast forward 2 phone interviews and 5 grueling on-site interviews, I ended up getting a role at Facebook as a production engineer. Does anybody know what a production engineer is? I expected that. Does anybody know what a site reliability engineer is? Okay, a couple. And I heard Aware's hiring for one. That's awesome. So a production engineer, the way I kind of think about engineering roles, and this is very much generalized, but I think of like software engineers. They're writing all the code, building the product, and then you kind of have this like sysadmin role, which is a traditional role where you're building systems, you're building out, scaling out websites. A production engineer is kind of a hybrid role where we do spend a lot of time coding and building things, but we also have a really heavy focus on the operating system, the performance of the websites, as well as scaling it out and making sure you're building a really reliable product. So for me, Facebook was a really great role, and in 2012, I made the 2,500-mile trip from Ohio to California, which was crazy. It was a lot of fun. I don't recommend doing that trip more than once though. So joining Facebook, I joined a team called the Global Site Reliability Team. And what was really interesting about that team is we didn't really own anything except the general reliability of Facebook. So every time you would see something like that on Facebook, when something's broken, my team was involved. We were the 24/7 team. We had folks in the United States as well as in Dublin, Ireland, who always watch the site and would really quickly, hopefully, respond to any outages. And we were the team responsible for going and triaging them and fixing them. We were like the first responders for Facebook.com and the mobile app. So this role was really great for me. I got to trade in a few thousand servers at Nationwide for a few 100,000 servers at Facebook. So for me, I was still pretty junior when I joined, but it allowed me to really get that scale, that exposure to scale and see how really big distributed systems work. And what's more importantly is seeing how distributed systems break. I learned way more by seeing all the failures than I did actually building these systems. So it was really great. So one of the goals, I think, as an engineer in any role that I've had, my goal is to automate myself out of my job. As I mentioned at Nationwide, I would write Python scripts to do all those things, or Bash scripts. This team, a team of about 20 individuals, over the course of about a year and a half while I was on that team, we actually ended up achieving that. We automated ourselves out of our jobs, which is kind of crazy and kind of scary because you don't really know what you're going to do next. But we actually achieved that, and about a year and a half, a little less than a year and a half into my time at Facebook, I kind of had the choice to go find a new role. Facebook's a really interesting company in that you don't get hired to a specific team, you get hired into a boot camp. So for 8 weeks, you go into this boot camp, you learn how to write code, you learn how to ship things to production, and then you get to go choose the team you're on. So I was kind of in this place where I had some, I've already been at the company, I get to go choose the team I'm on. And one area that I was always really, really interested in is how the internet works. I had very, very little networking background at the time, but I thought it was fascinating that I could use one little file and move people from continent to continent, which was just mind-boggling to me at the time. So I ended up joining the traffic in the CDN team, the content delivery team. Our job was to make sure no matter when you use Facebook.com or the Facebook app or Instagram or WhatsApp, whenever you had a photo or video show up in your newsfeed, that photo or video was delivered to your phone as fast as possible and as reliably as possible. So we'll talk a little bit more about this in the future, but basically we'd build maps of the entire world all the time to make sure your photos and videos showed up really quickly. So we manage servers all across the globe to, to deliver photos and videos. So if you've used Facebook in the last 8 years or so and you see any of these hilarious cat memes, you're welcome, because these are some of the projects that I worked on. These are some of the teams that I worked on to make sure they all show up to your phone very quickly. They're hilarious. Very little laughing. I expect a little more laughing there. That's okay though. I'm okay with it. So my last role at Facebook was I worked on a team that was focused around disaster recovery. So when you work at a company, or really any company, does anybody have disaster recovery teams, or like anybody that focuses on if like your website gets wiped out, what happens? Okay. Yeah, so it's really important, especially when you're a global company and you're worth a lot of money. You need to make sure if there are any big disasters, and there can be many different types, that your data is safe and your users can continue to use that website. So I worked on a team that we not only responded to these catastrophic events like a major hurricane hitting the East Coast, but we also were building tooling to simulate these events. So we would simulate a hurricane taking out most of the East Coast just to make sure Facebook stayed up, just to make sure we could still serve our customers, and we would actually do it. We would intentionally break the site just to make sure we could handle it if it actually happened. It was a really, really interesting role. So another thing happened was at Facebook, I had a son. My wife and I had a son in 2018, and he's pretty great. So, which leads me to my next role. Again, I was pretty happy at Facebook. I wasn't looking for a new role, but I was really looking to move back to Ohio. After my son was born, my wife and I grew up here, so we wanted to make our way back. So while I was kind of looking and exploring of ways to do that with Facebook, I also kind of hedged my bets just to see, if there are any other opportunities around. And I ended up deciding to take a role with Netflix. So I joined Netflix as a site reliability engineer, and I ended up moving from California back to Ohio. So I actually did make this trip twice. And again, I only recommend doing it once. But at Netflix, my role was essentially to make sure whenever you press play on your phone or you press play on your TV, that movie or that television show gets delivered there as quickly as possible. That circle that spins there while you're waiting is the enemy. And we also wanted to make sure as you're watching videos or TV shows or movies that we don't want that buffering to happen. So we were the team behind making sure that video delivery happened really, really quickly and reliably. So I was at Netflix. I joined in February of 2019. I was pretty happy in my role. I wasn't looking for another job, but one of the things when I moved back to Ohio was I wanted to connect with the tech community here. Things have changed a lot since I left in 2012. When I was in school, and even when I was working at Nationwide, joining a startup wasn't even an afterthought to me. I didn't even consider it. I know there were startups around, but it just wasn't something that I ever really thought about. So a lot has changed in the 7 or so years that I was gone, and I just ended up having coffee and lunch with folks and just kind of like seeing what people are building, seeing what is out there and what people are doing here in Columbus, because it's really amazing seeing some of the companies and what they've accomplished. So again, I wasn't looking for a new role, but I ended up meeting Matthew Benson, the co-founder and CEO of eFuse. And essentially, just to kind of give you an idea of what eFuse is, our mission is to unify the gaming community and provide it with limitless opportunity. There are over 160 universities in the United States that either have varsity esports programs or are building collegiate esports teams. So just like you have, varsity football players at Ohio State also has a collegiate competitive esports gaming team. Kids are getting full ride scholarships to go to Ohio State to play League of Legends. And they're practicing multiple hours a day. It's really, really fascinating. One big difference between kind of the traditional sports, landscape is, if you're an athlete in volleyball or basketball or football, you have sites like Be Recruited and J Huddle where you can go put your highlights and you can put your stats on those sites, and they can connect you with recruiters and universities and potentially even pro scouts to help you, find your career path and help you get there. But one of the things the team early on found is that doesn't really exist in the gaming community. When there's a lot of people who are gaming, they're really great, and universities are reaching out to them on Twitter, on Twitch, on Instagram, and saying, "Hey, are you interested in coming and playing for our university?" So eFuse is a platform to help unify that the gaming community in a couple of different ways. So the first we're doing is helping people build their professional gaming resume. So just like Be Recruited, you can put your highlights, for your football highlights. We want people to go put their League of Legends and their Fortnite highlights and have their entire resume on our site, including their stats. So you can go to somebody's page that's on eFuse, and you can go see their League of Legends stats. You can see they're verified where they are, what level they are. There's a lot more that I don't have on there, but we also want to be your education, your work experience. We want to be your professional gaming resume for gaming. So on the other side of it, we're working with universities and coaches and even businesses to provide opportunities. We want to help people get scholarships to go to school, full-time for gaming and play competitively and collegiately. We also want to, help people get internships and full-time jobs in this space. The esports and competitive gaming industry is just really blowing up, and there's a lot of opportunity to be had. And people are making really great incomes, doing this full time. So we want to help them, find those opportunities on both sides of the market. And then lastly, we have a community networking piece. This is where, we've been hearing a lot. People want a place for gamers to share their content, to network with other gamers. So we do have a social component to it as well. So if you're interested in hearing more, eFuseGG, we're also on the Google Play and the App Store. Cool. Enough about me. Let's talk about the origins of the internet. So, in the 70s or 80s, let's imagine we're at Ohio State, and we're here. We're a professor. We're a researcher. We're doing a bunch of great research in all these different labs across the university. We have people consuming that, but there wasn't a lot of collaboration between departments. So very early on, what they did was they're like, hey, let's network these computers together. So that's what they did, is they built this local area network for the university to connect all these computers up, to allow professors to email each other and to collaborate on this on the different research. So about the same time, the same thing was happening at Indiana University. So you had a lot of researchers collaborating, but it wasn't super efficient. And they did the same thing. They worked on protocols and they built out this network. And now, their university is sharing all this content and things are great. But what they found was, once, they had all this capability within their university, they wanted to then share it with other universities. So the question came up is, how do you connect these really big networks together? How do we share things, between these different networks? And that's where the internet comes in. Internetworking, connecting different networks together. So what they decided to do was, let's run a cable. So they actually ran a cable between these universities and connected them. So they have some networking gear there, and then they ran a cable. It might have been aerial, on the telephone lines. It might have been in the ground, but they basically connected the universities together. So everything's great. Now Ohio State and Indiana are sharing data. Everything's collaborative. Things are great. And then other universities get wind of this. So Illinois joins. They join this network. So now you have 3 different networks connecting together. And now you have Ohio University coming online as well. So you have multiple networks coming together. And this is kind of how the formation of the internet happened. You had all these networks coming together wanting to share information. So, this is, things are great. These universities, all these academic institutions are sharing and, participating in this network. But now you have outside businesses and even residential users who want to participate in this as well. And that's where the internet service provider is born. So you might pay Verizon or Spectrum or Time Warner or Comcast. You pay them money so that you can participate in the internetwork. They're the ones who provide that connectivity, and that's why they can charge the fees that they do to participate in it. So that's what they did, is they were basically the ones who connected all these networks together and then charged companies and charged their consumers for access to the internet. And over time, it just really became this viral expansion. More networks were being built, they were getting connected up, more networks were being built, and so on until, fast forward to today, where we have, billions of people online, billions of people with devices, and I don't even know how many networks that look like this that are actually on and participating in the internet. So it's really kind of amazing. It's amazing that it even works too. So sometimes it doesn't. Cool. All right. So we know kind of the origins of the internet. And how it kind of expanded, but what does the internet actually look like? How is it architected? So what I'm going to show now is a map that you might all be somewhat familiar with. This is the US interstate system. So these are all the interstates throughout the United States that help move people, help move goods, help move physical things throughout the United States. These paths were paved. I believe this was an initiative by Eisenhower in the 50s. Basically, they wanted to be able to move things a lot quicker. So they basically took all the most common paths that people were taking between some of the biggest cities, and they put down interstates so that people can move and goods can move a lot quicker. So next, I'm going to show you a map of the U.S. internet system. And as you can see, it doesn't look that far off. And this is not a comprehensive map, but it gives you a really good illustration of the actual cables that are carrying internet traffic around the United States. If you really kind of look and kind of squint a little bit, it doesn't look all that different from the interstate system. So the internet was being built, in the 80s or so, in 90s, by finding out where are people talking to and from the internet? Where is this traffic going to? So they laid the fiber, the framework for how the internet is actually built. So what is it that I actually did at Netflix? I said I helped make videos and movies and TV shows and photos and videos show up to your phone really quickly. But to kind of summarize what my team and my job was there is we essentially built ways for the internet. So I assume, is everybody familiar with Waze? Cool, I figured so. So again, looking at our US interstate map, we can see all the interstates, but if we actually look at it from, the perspective of an app like Waze, it shows us all the traffic, the real-time traffic information of all the roads, throughout the United States and really, worldwide essentially. If we actually, dive into Columbus, it will tell us in real time, where the congestion is in the road, where are the traffic accidents, and Waze's whole job is to make sure we get to our destination as quickly as possible. So, this right here is my normal route from home, right here from the WeWork facility. So it takes me about 23 minutes, but every once in a while, and this happened just yesterday, there was an accident on 315. So Waze redirected me to the next best route. Waze, has calculated all these different paths for me to get home based on all the conditions on the roadways and decided this is the next best way for me to actually get home. So, I might have been driving home and then all of a sudden there's a ton of congestion on that road as well. So Waze smartly, decides to take me, this is about 10 more minutes, than my original route, but Waze has determined this is the best way for me to get to my destination. And this is very similar to what my teams did at both Facebook and Netflix. We looked at all of the internet paths throughout the internet and built basically these maps of congestion of, the equivalent of a traffic accident is a fiber cut. Things happen all the time on the internet, and we would build maps to route around those issues so that you can get your photos or videos as quickly as possible. So how does the internet actually break? It actually breaks a lot and quite frequently. Just standard construction in the ground, people can accidentally dig up a cable. This happens very frequently. And another one is, people cutting down trees. So they might cut down the wrong branch. It takes out a telephone line that actually ends up being a really important piece to how the internet is routed. I've actually seen really big websites completely go down because some worker in the middle of nowhere took out a telephone pole and took out internet. It's pretty amazing that it can happen. But something just as simple as that can cause really major disruptions to the internet. And again, I already talked about this in one of my roles. One of the things that was really important to us, especially as the internet is architected, is making sure we can withstand natural disasters. These happen all the time, whether it's a hurricane, whether it's a tornado, whether it's an earthquake. These natural disasters can happen at any time, and we really needed to prepare for that and make sure we could handle it. So just kind of like one of the important things to think about, as we look at this hurricane is, you might say, yeah, that's only going to take out part of, the United States. But if we look at that same map of the global internet system, you can actually see there's tons of cables, there's tons of internet connectivity running under our oceans. And they're coming in at very important points on the East Coast and on the West Coast and in Asia. So any really big, typhoon, or whether it's a hurricane, they can cause really big disruptions if they hit Boston directly, or Miami is actually a really popular target. Tons of connectivity from Brazil comes into Miami. So when Miami gets hit by a hurricane, that's a really big deal for these companies to make sure we have alternate paths, and it might be going up to, LA instead. Cool. Now let's talk about the delivery of physical goods and how it compares to the delivery of digital goods. So let's look at Amazon in the 90s. So Amazon was a company started in the 90s, early 90s. Does anybody know what they first sold? Like, what was their first product that they sold? Yeah, books, exactly. Amazon was built to ship books. I think Jeff Bezos, if I remember the story correctly, he was ticked off because he couldn't find the books that he wanted in his local shops. So he decided to build a company based on the internet. Actually, they might have not even been based on the internet at the time, but to be able to, for anybody anywhere in the country to get any book that they wanted. And Amazon grew as the internet grew, and they became really, really popular. But with only their one single warehouse in Seattle, they had to ship all of those books from Seattle. Those books had to traverse all of these interstates. And, if you have to go from Seattle to, some of the really far corners of the United States, it actually could take a really long time. So it was very unreliable. If there were any outages or any, issues on the interstates, they had to be rerouted. So it just took a really long time to get those packages to their destinations. Very similarly, if we look at Netflix in its early days, they were, delivering videos just here in the United States, but, they might have been shipping these videos all the way across the country. And, one of the goals of working at these tech companies is you want to get the content that you're delivering off the internet as quickly as possible. You want to make sure that the time that it's spent traversing all of those unreliable cables is as short as possible. So they needed to kind of figure out this problem. So, which brings me to how Amazon solving their 2-day shipping problem is very similar to how Netflix scaled out their 4K video delivery. So is everybody familiar with 4K video? Really high definition, really high, bandwidth in terms of, what's required of your internet connection. Tons of data is being sent from that server to your device. So cool. So again, let's look at Amazon based just here in Seattle. So basically what they did was they looked at the US population map. They said, we're based in Seattle, we have a single warehouse in Seattle, but a lot of the people who are ordering products from us, ordering books, and by this time they were probably expanding to DVDs and other products, they realized that the majority of their users or their customers were not based in Seattle. So they took a look at this map and then they tried to figure out what to do. And the way they solved this problem was by deploying and creating warehouses and fulfillment centers all over the United States. So instead of having all of their items being shipped from Seattle, when you click that button on Amazon, it actually knows what item you want. It will go do a lookup to see where you are, what the destination is, and figure out exactly what warehouse has the item that you want, and then it will be shipped from there. So no longer do you have these really long wait times for packages. Amazon can get things to you really, really quickly. So very similarly, Netflix was looking at their problem, and they also looked at this US population map. They said, we're a California company, but the majority of our customers are outside of California. They're all over the United States. People love watching TV shows and videos and movies. How do we solve this problem? So in a very similar fashion to Amazon, they did the exact same thing. Is they said, we're going to take our entire movie and TV show catalog and replicate this throughout the United States. So wherever you are in the United States, when you go to watch Orange is the New Black, we know where your destination is, your TV or your phone. We know where you are on the internet. We know the servers that are closest to you that have the content that you want. So again, like as I mentioned, what we did was we built maps of the entire internet. So no matter where you are when you're on the Wi-Fi here at WeWork, they know as soon as you press play where exactly they want you to go to get that movie. They've already done the calculations. They've already done all the ways, the things Waze does for us physically. So this is, this is great, but if I actually simplified this in quite a big way. If we really looked at the footprint of what Netflix, their internet movie catalogs look like across the United States, it probably looks more like this. So Netflix and Facebook and Google and all of these companies, they have their catalogs or they have servers providing content for you really, really close to where you are. So it's a very, very distributed system. And these maps end up getting really, really big. And they have to change all the time. Because if you think there's a congestion right here, they need to get rid of that particular place and send you elsewhere. So very similarly, if we look at Amazon's interstate distribution network, it also probably looks more like this. Amazon has fulfillment centers throughout the entire United States. So not only have they been able to solve the 2-day delivery, but as many of you might know, they also have same-day delivery because they're in so many really big metropolitan areas. They have so many products and fulfillment centers. They can actually ship something to you within a couple hours. It's pretty amazing. So let's look at Netflix's movie catalogs here in Columbus. If you actually look at it, Columbus has a couple different entire catalogs of Netflix's content. Right here in Columbus. So if you were to pull it up right now, I would put a high probability, depending on the WeWork internet provider, that you're not even going to leave the Columbus metropolitan area to go get that movie or TV show. They're all right here, strategically placed, because we're such a big city and so many people use Netflix. The same with Facebook. Facebook has caches and servers all throughout, internet service providers here. Google, Amazon, they all have them as well. So at any given time, these servers could go away. No longer those catalogs, they're no longer available, whether it's a power outage, whether it's, the internet's cut. These are the types of maps that these companies build so that we make sure, even if you're watching a movie and one of those goes away, we will still send you to another place. You will never even know. It's actually really amazing what happens under the covers. So similarly, if we look at Amazon's warehouses here in Columbus, they have several fulfillment centers, surrounding us. So that's how we can benefit from same-day delivery and all those benefits of getting things to our door when we order it really, really quickly. So Cool. So I guess kind of like final thoughts on this is, my hope for when you take something, what I hope you take away from this is next time you buy something on Amazon, I hope you just kind of think about, all the complexity and all the decisions that need to be made for that package to be delivered to you. When it actually gets there, whether it's the same day or 2-day delivery or the next day, go look at the package and see where it came from. It'll tell you, if it came from Lexington, Kentucky, or even here in Columbus, Ohio. And similarly, next time you go press play on Netflix or Facebook or Google, just kind of think about, some of the technology and some of the, all these decisions that are being made for that video or movie or TV show to show up to your TV really, really quickly. So, some final thoughts. One thing that, one of the questions after moving back, I had a lot of conversations with folks, and two of the questions that came up quite often was, one, should I move to Silicon Valley? And two, why would you leave Netflix to join a startup here in Columbus? So for the first one, why? I think like going to Silicon Valley is a really personal question, or moving, going to work at a tech company, even if it's New York or Austin, there's a lot of different tech hubs. Like, I think it's a really personal question. For me, at the time, in 2012, when I decided to move out there, I really do believe it was the best thing for me and the best thing for my career. Like, I would not trade my time in California for anything. But I think, one thing that I think back on is I really enjoy, coming back to Ohio, it's really made me appreciate, what I had out there and kind of the career growth that I had. And coming back here and seeing all these companies like Aware, Root, Cover My Meds, Improving, Vibe, like they're building some really amazing things. So all those things that I, went out to the West Coast to kind of learn, we have that here in Columbus. And that's one of the things I'm really excited about, and one of the reasons why I also left Netflix is I want to be able to, I love those companies. Like Netflix and Facebook were really great. I'm really excited to help build some of those companies right here in Columbus. I know we have the talent, I know we have the people, and I know we have the really great and smart, entrepreneurs to do it. So, yeah, I'm just really excited to be back here and being a part of this community. So, thank you.
So we talked a lot about you talked a lot about Facebook and Netflix, your experience there, and kind of how that shaped you and what you were doing with the internet. Can you kind of talk a little bit kind of about the culture of Facebook and now like the cultures of companies in Columbus?
Sure. Yeah, I think Facebook has a really interesting culture. Some of the things I'll compare Facebook and Netflix a little bit, and then I'll compare to Columbus. So, Facebook had a really interesting culture where they they want to hire young, not just young, but they want to hire across the spectrum. They would hire really, really senior folks that are doing industry changing things. And at the same time, they spend a lot of time hiring really junior folks, like myself, like coming out of college and coming out of Nationwide. It's really interesting. Like they really put a lot of focus on not only building amazing things, but also helping you grow as an engineer. And for me, like being put in that type of environment, and as I mentioned, that production engineering role was perfect for me. I am not the engineer who's going to make things look pretty. Like, I don't want to go and write CSS. I want to scale things. And for me, like being put in that environment and just being able to kind of like thrive and fail, but grow at the same time was just like really, really great for me. And I appreciate their culture in a huge, huge way. It isn't without its flaws, but at the same time, Netflix is a very different culture in terms of kind of like thinking about their people and the people they hire. They really only hire senior folks. So they're only going to hire you if you have X number of years working on this very specific thing, and they hire you for a very specific role. The reason why I got a job at Netflix is I was working on, one of the largest websites focused on video delivery. I worked on some really crazy projects there, so they wanted to hire me because of that. So I think it's a very different just like mentality on how they hire and grow people. And I'm not actually saying either one of those is wrong. Like, they're making very intentional decisions. Both are really, really successful companies. They must be doing something right. But it's just really interesting to kind of see that dichotomy between the two. Yeah.
Yeah. Well, and so you talked a little bit about Facebook hiring people to learn and to grow. And part of that typically is making mistakes.
Mm-hmm.
So could you maybe share with us what the biggest outage you caused was?
Oh no. Yeah, I can. Okay, so one of the projects I was working on, as I kind of mentioned, or you saw that screen where you had all those different movie catalogs throughout the United States. I was working on that same project at Facebook, where we were shipping these servers to internet service providers. Photos and videos got delivered from them, and I made a mistake. This was fortunately somewhat early on in the project, but basically I'll kind of cut to the chase. I broke Facebook photos and videos for several million people in the southern, Texas, Mexico, and surrounding states for probably 30 minutes. They had a really bad time, and I didn't realize why. And for any software engineers out there, basically, I'll give you the reason was when you try to read 128 characters from a byte array, and there's a null in the middle, you're going to have a bad time in C++. So I learned the hard way. So I broke Facebook for millions of people.
I'd say that's a pretty good outage.
Yeah, it was. But the thing is, one of the really amazing things about Facebook is I did not get in trouble for that. Nobody reprimanded me. The important thing about, I've seen people lose millions and millions of dollars. But one of the really cool things about Facebook is they have what they call sev review. It's whenever there's an outage. It's basically an outage review, a post-mortem of what happened. And the really important thing is to really understand what happened and make sure it doesn't happen again. They had a really big focus on not focusing on the individual, but focusing on what processes led up to that happening. How could we have let that particular thing happen? So I've seen people just make really catastrophic issues and human errors, but we didn't focus on that. We focused on finding the root cause and just making sure that that particular thing didn't happen again, which I think is really, really important for any company and any culture.
So now that you're back in Ohio, how would you compare the compensation between Silicon Valley and Columbus?
Oh man, Silicon Valley, they have a lot of money, and they pay you a lot. So when you get that job offer to go join one of these tech companies, it's going to look pretty good. It's going to look pretty good on paper. But one of the things, even when I moved out in 2012. What I was paying in Dublin, Ohio, was I would have paid 4 times that amount out there. So I literally paid twice as much for what I paid in Dublin for less than half the space. And at the time, I had a fiance. We didn't have roommates. It's really common to have roommates out there. So I mean, California is great. The Bay Area is really great, but it's really, really expensive to live. And I think, especially in Columbus, Ohio, we have a pretty good cost of living here. Based on what we make versus what we pay for all the things. I think it's really good, and yeah, don't discount the amount of knowledge and experience you can get, but just really think about the compensation that you'll get out there, and think about owning a home someday if that's something that you want to do. That's one of the reasons why we moved back. We really wanted to own a home, and it was almost unattainable to do that in the places that we wanted to do out there.
Cool. So last question before we open it up.
Yep.
What's your favorite game to play?
My favorite game
to play.
Okay, this is not going to be like a competitive esports game, but the game that I am most addicted to is Factorio. Has anybody played Factorio?
Ooh, okay.
Is that
That's
game not
one.
the most addicting game in the world? Cracktorial, I agree. It is so much fun, and especially, I mean, as a software engineer, I love like it just triggers all of the things that I love about coding, and it's fantastic. Like, don't I honestly don't recommend playing it because you're gonna suck up a lot of your life, but it is just such a fun game, such a fun game.
Great, thank you. So now we're gonna open up the floor to questions. You have two options. You can just raise your hand and I'll come to you and hand you the mic, or you can make your way on up here and ask it in the fancy brown chair.
So obviously it makes sense to talk about traffic in terms of Amazon and Netflix, but I guess how can a startup or how can eFuse use this knowledge today? Or if maybe not, when does it become necessary to use this knowledge?
Cool. So the question is, how can, I guess given my experience in traffic, how do I apply that towards how we're building the eFuse startup? Yeah, it's a good question. One of the things that it's a common trope, I guess, at Facebook and when you work at these big companies, that you get so ingrained in the way that they do things. Like when you go to Google or Facebook, the way they build software and the way they build platforms, there's so much tooling and scaffolding for you to be really productive and ship a new feature to 1 billion people within like an hour. It's incredible. And like they just have so much for you. But one of the common tropes that I heard a lot there was you get so ingrained in how you do things at these companies that it's really hard to leave and do other things. And I've always not believed that, because I think there's a lot of things to learn. Like instead of like learning and really understanding the tools that you're using at these companies, understand the fundamental concepts, understand like the fundamental building blocks of which these are built upon that are available to everybody. Amazon Web Services, Google Cloud Compute, like all of the things that make working at these companies and building software and products really, really great, you can distill those down into their fundamental building blocks. And that's where I try to kind of focus on understanding those concepts more than learning the tools. Obviously, you have to learn the tools to be productive. But I think another thing that really helped me kind of understand like the building blocks of building infrastructure or building, a CDN is like the failures. I learned so much from seeing how Facebook failed. I kind of mentioned this in the talk. I learned way more about when things failed and understanding all those different use cases, because they helped me shape how I build and design things in the future. I've seen those failure scenarios and like just thinking about that and participating in those outages, those outage postmortems, I learned a ton. So I to kind of go back to like your original question is, for me, when I left Netflix and Facebook, I had to learn AWS. I hadn't really used Amazon Web Services and all the things that they do, but I didn't know Docker. We use Facebook's equivalent of Docker to, containerize our apps. And I don't mean to get too technical, but for me, like I was able to go and translate, the fundamental building blocks into what I wanted to do and learn these types of things. And I will say in 2020, it's incredible how much and how quickly you can build websites and scale them out with something like Amazon Web Services. It like really makes you feel like a superhuman to be able to go and spin up load balancers, which is really hard to, traditionally, if you're doing it manually. It's really incredible. So.
Thanks for your really informative discussion. I was curious, kind of along the same lines of learning from failure at Facebook, and some of your experience at these like kind of cutting edge tech companies. What was different for you moving from Nationwide to tech and the startup world? And what sorts of lessons would you have for a more conservative culture, as I assume Nationwide would have been if you were to return to an environment like that?
Totally. Great question. Okay. So Nationwide, Nationwide was amazing for me. Like it really allowed me to grow in kind of the areas that I wanted to. But I'm going to go and answer your last question is like, could I go back to a Nationwide? I think it would be really hard for me today to go back to a Nationwide or a traditional. I'm never going to say never. Maybe I'd come back, like I don't want to ever, put anything out of the possibility. But one of the things that there's a big difference between a, an insurance company and a tech company. When you work at an insurance company or a banking company, technology is really there to support the business, and in general, they provide a lot of process to make sure the technology and the things you do don't impact the business in really big ways. Nationwide had a lot of process around doing things, like very simple things. I would have to do a change request. Is anybody familiar with change requests? Like, Facebook didn't have any of that. Like, I would say, like, one of the, like, to really compare them, Facebook was very much, they empowered the engineer to make the right decision. So if I went and pushed something that now this null array, or, this null string, like, and I broke something, like, they empowered me to make that decision based on the knowledge that I had at the time without kind of providing that process around it. So I would say, like, that's one of the biggest differences is you just don't have the change management, the process at these companies. They really empower the engineers to build the technology, to decide what projects you work on, and kind of like it's very much bottom up. But what's really fascinating as well is over time, Facebook did actually have process, and Facebook would never ever say that they're an ITIL company and they have ITIL processes, if anybody's familiar with that. But if you really look at some of the ITIL things, like there is some event management, there is some, not really change management as much, but when you think about outages and postmortems, like they actually do a lot of things that they've naturally done over time that really align with ITIL. They would never say that, but yeah, I think process and would be tough for me. Yeah.
Hi. You spoke about the circle, that when you put the show on, you have the little circle.
Yeah.
Do you think, you said it's the enemy. We see it's the enemy when the kids are trying to put a show on and,
Totally.
they hate it. Yeah. Do you think it's ever going to go away altogether? And if yes, what's going to cause this to go away?
So the question was, when you start a show and you kind of see that the circle on, say, Netflix or YouTube or whatever, Facebook, will that ever go away? I think it's going to get better. I don't think it will ever completely go away. But the thing that's like really fun about that type of question is somebody might pose that question in a meeting is, how do we make sure that goes away? Like, how do we, or if it's not going away, how do we like make it, how do we fake it? So like what you could do there is, instead of like, when you're kind of flipping through movies, you could actually send that movie to your client device before you even press play. Like, there are so many ways in which these companies kind of fake being really, really fast by just being kind of clever in doing those things. So I mean, it's always going to happen. The internet is always going to be down at some point in time. But like really thinking about this distributed, model for delivering content, I think is only going to get better over time. Yeah. Yeah.
So, what do you think of Netflix stock and coronavirus? No, I'm joking. Sorry, I was hesitating. Probably a bad joke. Sorry. But I wanted to ask you about the maps that you showed with the internet, the cables.
Yeah.
And if you would want to share anything about the layers of internet, like especially the top layer, and that in relation to probably the content delivery networks that you guys were, I imagine, collaborating with in your role. But yeah, I'm very curious about that aspect, if you could expand on it.
Sure. So this talk, I had given, not this talk specifically, I'd given another talk called Demystifying the Internet Beyond the Cloud at a few different places. I did it at LAPSA. I had done it at some companies. I did it at Root Insurance. I think I'd given it some other place. And that talk was a very, very technical talk that went into kind of all the layers of the internet, essentially, and how packets and things are load balanced. And this talk, in talking with Andy and Kevin, like this was a derivative of that, but we wanted to make it a lot less technical, so that because this is like a really, this is a very diverse crowd. So if I ever do that talk again, I definitely recommend it because it really goes deep into the protocols and the layers and how the internet works. Assuming you have like a single server and it kind of just expands out until you're building this global website. But the map I showed on there with those fiber cables going across the United States, that's a very, very high level map. There's probably an order of magnitude or two more at least that just don't make sense to show on a map, but there are cables all throughout the United States, and there's new cables being run all the time, like in the ground, overhead. So internet connectivity for some of these big companies is one of the most important resources. When you're a company that's growing as fast as some of these are, they're literally buying up as much as they possibly can to be able to serve customers, to be able to make sure that spinner isn't showing up. Like they want to have as much connectivity, as much capacity, not only to serve the day-to-day traffic, but also in those disaster scenarios when there's really big issues, they want to have enough buffer and enough capacity to be able to absorb a lot of those things. So it'd be really hard for me to go into the different layers, but when you think about the way you kind of think about it is you have these different internet service providers, and in the industry they call them like tier 1. So you have like AT&T, Comcast, Earthlink, Spectrum might be one of those. These are the companies that actually physically lay the cable across the United States. They are the ones paying the big money to trench this stuff and get it and have it connected at each end. And then from there you have the tier 2 ISPs, the tier 2 internet service providers. These are the more regional companies that might be, say, just here in Columbus or might be here in Chicago, and they actually pay, they're still an internet service provider, they're still providing internet access, but they'll actually pay AT&T for connectivity. They'll actually rent their cables out so that they can provide connectivity. They look like a large ISP, but really they're just renting, fiber connectivity from someone else. So there's a lot of different layers to it, and yeah, I won't go into it too much deeper than that, but happy to talk after. It's really fascinating.
And so now we have time for one more question. So who would like to ask the last question of the night?
Better be a good one. Just kidding.
Better be a good one. No one? All right. Here we go.
Uh-oh.
How do you feel about low orbital satellites providing alternatives to land platforms? And do you think that's like a viable future? And if that's not interesting, what do you think the future of infrastructure looks like?
So the question was, do I think that Elon Musk's low orbital satellites that Tesla wants to provide is the right way or the future of internet connectivity? My answer to that is I really just don't know enough about it. When you think about building a website and say you're Netflix or Facebook, you think about the latency between your devices and the path that it's going to take. So I don't know the exact latency between going to that low orbital satellite back down, but there's going to be some penalty there. And when you're not going over a fiber and you're going over I don't know if it's lasers or however it's done, there's going to be loss there. There's going to be a lot more loss than that crystal clear fiber cable being run in the ground. So I don't know. I just don't know enough about it to really know. I think it's really cool that Elon is doing that type of thing, and I think there will be some really interesting government applications of it. They'll probably be a big consumer of it, but I just don't know enough to know if it'll be a big part of our future. And then the second question was, what do I think the future of infrastructure is? One thing I think is really interesting, and I thought I think this has everybody heard of Google Stadia? How they're basically Google is building this set-top box that you can play games on where you're streaming that game from a server. So you don't no longer have the graphic processing unit, the CPU there doing the hard work. They're offloading that to some server somewhere else. And I think it's going to be really interesting to see if Google's able to pull that off, because that's going to be really, really expensive for them one, just in the hardware that's going to be required, but they also have to really spend a lot of time like strategically placing these badass, whatever the actual hardware is for these things, like right here in Columbus, Ohio. They already do this for caching, photo and video. Like that, they've been doing that with YouTube for a long, long time. But I think it's a whole different aspect when you think about how do you build really high performance gaming, computing engines and putting them in these places. Another really big constraint for building this type of thing is power. When Google, well, they do have a data center out here, but normally when you do this type of thing, you have internet exchanges where you release space and power. Power is one of the biggest constraints on the internet today. Is you actually can't even put all of the infrastructure you want, the physical servers and the networking gear, because it takes up too much power. So I think it's going to be really interesting to see how they pull that off. And to kind of like fully answer your question, I think it'll be interesting to see if that is kind of paves the path for future where we have these dumb devices, that are just screens, and all the real processing and the important stuff is happening elsewhere. Probably close, but I think Google's got a lot bigger ambitions for this type of thing than just playing video games. Like I think there's a potential future there that we just don't see yet, but there's a longer term path there. So it'll be fun to watch and see it play out.
Cool. Well, thank you, Patrick, for presenting and
Thank
putting
you.
up
Thank
with.
you for coming.
Yeah. But everyone that came out tonight, I know there's many things that you could be doing in this great city. So we definitely appreciate you taking the time and making it out to the event, especially if this is your first Columbus Web Group. Thank you, and we hope to see you at one of our next events. As I said, we're taking off March, but we'll be back in April, and it'll be the craziest event we have ever done. Yeah. Yeah. You have to sign an NDA when you walk into that one. No, but if you haven't met either Andy or myself, please come up and introduce yourself. We are going to be heading over to, why can't I think of what that bar is? Yeah, Pine House, which is just right down the street. We do have a little bit of food, but I know we do have to get out of WeWork here in just a few minutes. So again, thank you guys. And lastly, let's give one more round of applause for Patrick.